My lab report on our second lab of the year, charge tape revisited. So the introduction of the purpose. The purpose of this experiment is to estimate the magnitude of excess electrical charge on a piece of clear tape by combining qualitative observations of the tape on tape electrostatic interactions with quantitative computational models. In the simulation, each tape is represented as a uniformly charged line, charge evenly distributed along its length, rather the concentration at the point, as compared to in the first lab. And Coulomb's forces between the two faces are summed across the distributed charge while gravity acts on the suspended tape. By adjusting the tape charge in the model until the upward electrical force balances the tape's weight, producing a floating equilibrium, we determine within an order of magnitude the charge required to reproduce the observed behavior and identify the assumptions and idealizations needed to make this estimation. So introduction to physics principles, similar to Lab 1, we have Coulomb's law, so K, or the K constant, the, the electric constant times the two charges that we're looking at over the distance squared. So it's the electrical force to charge objects. Um, and then we have superposition and point charge approximation. When modeling the system, each piece of tape is approximated as a point charge located at its center. This simplification allows for us to observe the electrical interactions between them and using Coulomb's law to approximate them. Gravitational force, basically how gravity works. Gravity pulls us down because of mass and the gravitational constant of 9.8. So the results of the experiment in the computational model, it was adjusted to charge the two uniformly charged tapes more as strips instead of point charges. So it's uniformly charged across a line. And we approximately the magnitude of the force was approximately 3.0 e to the negative 6, while the magnitude of the gravitational force, or newtons, while the magnitude of the gravitational force on the tape was 7.6518 e to the negative 6 newtons. Since these forces are on a similar order of magnitude, the model shows that electrostatic interactions between the tapes are strong enough to partially counteract gravity and produce the observed lifting behavior. Small differences between the forces can be attributed to experimental limitations and modeling assumptions. So in the process of making the code, we took the starter code that was given to us and we had to implement our own data and then also apply the code that we used for the first lab into calculating the electric field. So here were the detailed instructions for how to create the line charge. And here and to the left, to the right, you have the visualization of the tapes and calculating the electric field and force. Um, in terms of the job that we had to do, it was changing changing the estimated values. In our case, we redid the experiment, so we had to change the values in terms of distance, mass, and distance, mass, and charge for the tape. And then this was the result, the magnitude of electric force of 3 to e to negative 6 newtons, and then the magnitude of the gravitational force, 7.65 e to the negative 6. And then here you have the visualization, the red ball simulating one line of tape and the blue representing the other, or the other tape. Basically, the white arrow is showing the force pulling, sorry, pulling the tape upwards, and then also the force or the magnitude of the gravitational force. Some errors, possible errors in the experiment are the handling of the tape, so our charge transferring to the tape of the charge, possibly messing with the tape of the charge. The distance measured, because the floating wasn't a dramatic effect and it didn't hold long enough to measure. There are some miscommunications in terms of that measurement, and then a computational misrepresentation. Because of these two things, there is the possibility that the computational model is not accurate, and therefore you can't really you can compare and contrast both, but it's not an accurate comparison. So applications, the what if questions. if you modeled each tape as a single point charge, what charge would you estimate and how would you compare it? So from it, from the point charge model, the estimated charge was 9.2 e to negative 10 coulombs. When you when But instead of the line charge model, which we did in this experiment, the estimated charge needed to reproduce the same floating behavior, which is typically smaller than the point charge estimate, because the distributed model accounts for parts of the tape being closer together. And then why? They differ in distribution because of the point charge model, our charge is concentrated on the tape center instead of the distributed, so it's a lesser, I guess, force. And then in the line charge model, yeah, the force is effectively the sum of all the forces between the small elements. So this better matches a real geometry of the linearity of the tape. So the line charge estimate is more likely to produce a closer charge, which makes it the physical situation better spread along the tape. And that was my presentation. Thank you for listening.